Okay, in this problem, we have a boat that leaves port, travels 14 miles, heading south 40 degrees west, then makes a turn, heads another 25 miles. This time, instead of giving us a bearing or a heading, we're given an azimuth 310 degrees. We'd like to figure out what heading should be set to return to port. So we mark a point down, and then we're going to draw in our axes. And I draw in my first path here in red, where I travel 14 miles. That takes me to a second point, so once again I'm going to draw in axis as a guideline. Now, we're talking about an azimuth of 310 degrees, so I go around 90 to 180, 270, and 310 is a little bit past the 270 mark. And so that's what I've done here. And then draw in my second line. Here it should be 25, so I'm making it a little bit longer than the 14. And then just a little bit of relabeling here. 14 and 25. Now the way I've drawn this picture, it looks like I'm north of the original port. Whether or not I actually am north of the original port is something that we'll find out as we work out the problem. So we have a triangle here, and the way I've set this up is so that the triangle actually is a right triangle. You can go back and confirm on those two headings that that will be a right triangle. And so we want to solve that triangle. First thing I'm going to do here is find the distance. I can do that by the Pythagorean theorem. And when I solve, I'll get D is 20.518. So I'm sorry, 28.653. Ignore that first little mistake there. Okay. And now that I've found D, I'm going to go ahead and find the angle there. Call it theta. And then tangent theta would equal opposite over adjacent. Now why not use D even though I've found it? Well, typically in these problems, D is a found result, and we like to try to avoid using that as much as we can. So I don't need to use a found result here. 14 and 25 are given to me. So I use that here. And from that I find out that theta is 29.249 degrees. Okay, and now it's just a matter of using that to figure out, okay, how in the world am I going to figure out the heading backwards now? So what I've done now is I've drawn the picture again. Right here is port, that's where I started, and then traveled south 40 degrees west to a second point where I've again drawn in a set of axes to help me with the guideline, and then I traveled on an azimuth of 310 degrees, which by the way is the same as north 50 degrees west. And eventually I ended this new point right over here. Now to compute the heading, we need to know what the angle that I've now marked is. What we know is that this little angle here that's formed with a red line and the positive y-axis is 50 degrees, because an azimuth of 310 degrees is a heading of north 50 degrees west. So using that, I can actually find that this is 50 degrees. Now how do I find that that's 50 degrees? Well, I can find that that's 50 degrees because those two y-axes are parallel lines. So I have two parallel lines there intersected by the red line, which is a transversal. So because of that, alternate interior angles are of course congruent. So now that I know that is 50 degrees, and then I also know that the angle inside, which is what I found from my previous problem, or the problem I just worked out, was 29.249 degrees. So that big angle is 79.249 degrees. And so therefore, this big angle that I'm looking at right here, from the south line to my point that I would need to travel on to get back to the port, is 79.249 degrees. So my heading would be south, because I'm below the north-south line, 79.249 degrees, and I'm on the east side, so it would be east. So that would be my heading. So it turns out that I actually did not even need to know that 28.653. And sometimes in these problems you will end up finding stuff that you really don't even need. So the fact that we found it, we didn't need it. We just now know how far we have to travel. 28.653 miles on that heading of south, 79.249 degrees east.